Good morning. Happy Monday. My name is Kobe Flat, and for the next hour, we are going to go through the MAP4C, our Grade 12 Foundations for College Mathematics course. It's a bit of a dark, gloomy Monday out there, but we're starting the day off with some trigonometry. So get excited, team. We are also in our 8th week of our 9-week radio Zoom class. So if you're not super excited about trigonometry, maybe you can be excited that this course is almost done. We have 8 classes remaining to get through the rest of the IL material and then have a week off, reset before we change gears and move to our next course, whatever it may be. If you still need any credits and you're curious to find out what is going to be broadcast during term 1B, please reach out to us here. See if there's anything else that we can help you with. If you are feeling assisted by the radio Zoom courses, you might want to consider taking one that's being broadcast next term. Then you don't have to work through the IL booklet on your own. Remember, the IL booklet and the radio Zoom courses are all the same material. You don't have to worry about jumping into the radio Zoom course because it's shorter or it has easier questions or it's all the same. Our radio Zoom courses just allow us to break down all of the concepts in the IL course, further delve into the background behind extra questions, what it is that you need to know to help you feel super confident and gain the curriculum expectation understandings. So if the course that you need is not being offered next term, don't worry. It will probably be coming up, or you might even be able to find a course that we did last year that just hasn't been rebroadcast yet on our WASA YouTube channel. If that's the case, you can go to our WASA YouTube channel and look through the playlists, see which courses are listed there, and maybe you can get a jump start on the next course that you need. Today we are beginning week 8. We have a full week this week. Remember, we only broadcast Monday to Thursdays. Fridays are that chance for you to get caught up on any outstanding assignments, be submitting your lessons. So we have 4 days this week and 4 days next week. We're going to finish lesson 17 today, look at lesson 18 for Tuesday, lesson 19 for Wednesday, and finishing with lesson 20 on Thursday. We're going to wrap up our 20 lesson MAP4C course this week, leaving next week simply for review. This course does have an exam. It's not something you have to stress out about. It's more like an open book exam. But to help you review those concepts, things that we learned way back on September 2nd, we're going to do review so that you can be prepared to write that exam when you are finished all 20 lessons. Without further ado, let's jump into lesson 17. We're going to continue exploring trigonometric ratios to further understand what they are, as well as how and when to calculate. Quick refresher, since we've had the Friday and the weekend since we looked at lesson 17 part 1. When we are going through trigonometric ratios, it's important that we are familiar with the term hypotenuse, what it is and where to find it and how to find it. If you remember, if you were with us for not Friday, I just said we don't broadcast on Friday, for Thursday's lesson, we know that the hypotenuse is the side opposite the right angle in a right triangle. That hypotenuse is always the longest side, and it is always opposite the right angle. We know how to identify that right angle. because it forms that perfect square, that perfect box, and that right angle means that the angle is 90 degrees. If you see that little symbol, if you see that little box in a corner, it's a right angle, it's 90 degrees, and always opposite that is our hypotenuse. Now, sometimes you might need to calculate the hypotenuse, and if you have to calculate another side and you know the hypotenuse, you are looking at using the Pythagorean theorem. For any right triangle that has that 90-degree angle, remember, the area of the square of the hypotenuse is equal to the sum. Remember, sum means we're going to have to add. It's equal to the sum of the areas of the squares of the other two sides. So that's just a long way of saying that we have three legs, so to speak, of a triangle. They're also the sides. We know that across from the right angle is our hypotenuse. We know that the other two sides then are our legs. And when you add those other two legs together, when you have the sum of the areas of the squares, so it's not just adding side A to side B, it's adding the squares. So A squared plus B squared equals C squared. That will give you the hypotenuse. So in right triangle ABC with the hypotenuse of C, we would say A squared plus B squared equals C squared. Sometimes you need to find a different side. Sometimes the hypotenuse is given to you and you might need to find leg A or leg B. You can simply rearrange the formula to find what is the length of side A or B, or you can use it to find C by finding the square root. And we practiced that last Friday. If you want a refresher, you can go back and watch the recording. You can try a few of the support questions in your IL booklet. We are going to move on to make sure that we get the other trigonometric ratios in today. But if we've got time, we'll go back and practice some more of those too. The last thing I want to remind you of are those trigonometric ratios that we're going to cover. Last week we got into a little bit of sine and cosine. We saw tangent, didn't get to calculate tangent, but these trigonometric ratios are going to help with finding, when we're working with right triangles, finding either unknown angles or unknown sides. When you are looking at a right triangle, you're going to be given an unknown, and it'll ask you to find the length of the side, find an angle. When you're doing that, you really have to pay attention to labeling your triangle. We have to know what is our marked angle or our referenced angle. Once you have that, you can start labeling whether side or legs are opposite, adjacent, or the hypotenuse. We know the hypotenuse is the easiest one. It's always opposite or across from that right angle. It's usually the longest side. And then from there you have to find what's your reference angle to determine which is the opposite side and which is the adjacent side. Once you are comfortable with naming those, then you're able to plug them into our trigonometric ratios. To remember our trigonometric ratios, we use the acronym SOHCAHTOA. SOHCAHTOA. SOHCAHTOA is simply an acronym for if we know the opposite side and the hypotenuse, we use sine. Sine is the sa in SOHCAHTOA. If you know the adjacent side and the hypotenuse, you will use cosine. So the part of the acronym CA helps us to know that cosine is adjacent over hypotenuse. And that leaves our last one. If we know opposite and adjacent, we're going to use tangent, and that is the TOA. You use tangent if you have opposite and adjacent. So remember the acronym SOHCAHTOA for trigonometric ratios. We practiced labeling the sides on Thursday. Today we're going to jump into the sine ratio to start. If you're following along on page 12 of your Unit 4 IL booklet, we find that the sine ratio can be used to calculate an unknown angle or an unknown side in a right triangle. To find either of these unknowns, the opposite side and hypotenuse are used. Because of our acronym, the first part, SOHCAHTOA, the SA is the SOH, so if you're using sine ratio, the opposite side, and the hypotenuse, the O and the H, are used from an angle of reference. So on the board in front of me, I have a diagram of a right triangle, and it has our marked angle. That marked angle has that curve. It's letting you know this is the angle that we're working with. Ding, 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 ding. That's the one we want. Opposite of that marked angle is our opposite side. We know the hypotenuse is opposite that right angle, that 90-degree angle. That's our hypotenuse, which leaves the adjacent, that side next to our marked angle, as the adjacent side. It's always easiest to identify the hypotenuse, then the opposite side, and that usually means the adjacent side is left over, not always on the left. The sine always uses the hypotenuse and opposite sides of a right triangle. Now that is important. If you don't have a right triangle, the sine ratio is not going to work. So sine uses opposite and hypotenuse, which is saying that when you have angle A, if angle A is an acute angle in a right triangle, then sine A, that's telling us remember our angle is always capitalized, so sine A is equal to the length of side opposite, that's the O in angle A, with the length of hypotenuse, that's our H. Our S, we should say, equals O over H, our opposite over hypotenuse. Let's practice. The example question that I have on the board in front of me says, determine the length of side P, because it's lowercase p, in triangle MNP. When you name a triangle, you're simply naming the labeled angles. So this triangle has a right angle that is labeled as N, an acute angle that is labeled as P, and another acute angle labeled as M. So we call it triangle MNP. Now, side P is opposite to angle P. Because we want to know the length of P, we need to identify our knowns. The length of P is our unknown. What we do know is the hypotenuse, because we have our right angle. So across from our right angle is our hypotenuse. We know that the hypotenuse is equal to 225 feet. The other knowns that we can see here, we can see angle P. So we do this little greater than sign for angle. It's angle P equals 60 degrees. And side P then is the opposite to angle P. So we have hypotenuse, angle P, and it's the opposite of angle P that we want to know. When we look at what we have hypotenuse, we want to know opposite. Think of our acronym SOHCAHTOA. So we have hypotenuse, which means we're not going to use TOA. There's no hypotenuse in TOA. It's tangent equals opposite over adjacent. The ones with hypotenuse in it are sine or cosine. Cosine is the ca, so cosine equals adjacent over hypotenuse. Nowhere in our knowns did we write adjacent. So we're not going to use cosine because we don't have an adjacent. That leaves us with sine. We're going to use sine because it talks about opposite and hypotenuse. So let's write that in, sine, and then here the angle of reference is P. So we say sine P equals opposite over hypotenuse. Now we have our knowns. We've identified the variables that we can. So let's plug them in. Let's do that substitution formula that we've been working on all course. We're going to plug in angle P for 60 degrees. We're going to say sine P is actually 60 degrees. So sine 60 degrees equals opposite over hypotenuse. Now I'm going to do this simultaneously so that you can see as we go. We can also put this as sine P. Remember last Thursday we worked on naming sides in different ways. So we could also say sine P opposite would be line MN. So we say line MN over our hypotenuse, which is MP, over line MP. So you can see the different ways of writing this. You can either say opposite or you can say line MN, or remember the other way of naming it is simply by lowercase p, saying it's side P. So side P divided by hypotenuse we know. Side P is what we're trying to find, that lowercase p, the length of side P or line MN. We're going to keep that as lowercase p because we don't know what it is. That's what we're trying to figure out. But we do know hypotenuse. Hypotenuse is 225 feet. So now we have sine 60 degrees equals P over 225. We want to get that unknown variable by itself. We want to find out what P is. We need to get P alone. Right now it's divided by 225. We want to get rid of that 225 so that we can get P by itself. In order to cancel it out, we have to do the opposite operation. Opposite operation of division is multiplication. So we're going to multiply by 225. That's going to cancel that out, leaving us with just P, which is what we wanted. But whatever we do to one side, we have to do to the other side. That means we have to say sine 60 degrees times 225. Because whatever we're doing to one side, we're doing to the other. Now is when we can look at our scientific calculator. You can pull up Desmos, that online free resource, and we're going to make sure that whatever calculator we're using, it's in degrees. Remember, we want it to say degrees. You'll notice there are buttons that say, it says sin, S-I-N, but we say sine. That's sine. Cos, C-O-S, is cosine. Cosine. And tan is tangent. So if you see the buttons that say sin, cos, tan, that is our sine, cosine, and tangent. We're going to click that sine button. When you click sine, it's going to ask for the degrees. What is the angle that we're referencing? So here we're referencing 60 degrees, and we want to be sure to close that bracket. Close the bracket and then type times 225. We are saying sine 60 degrees times 225 equals P, which means that P equals 194 decimal, we'll say decimal 9 feet. So that means that the length of side P is, and we can round up, we can say it's 195 feet. If it doesn't tell us to go to a certain amount of decimal places, you can always gauge if hypotenuse is as a whole number or your other side, your adjacent side is a whole number, you can keep it as a whole number so that it's consistent. So the length of side P is 195 feet. And we can always do that quick mental check. The hypotenuse is supposed to be the longest side. So if side P is 195 feet, that's less than 225 feet. So that means that we are most likely sitting at the correct calculation. If our calculation spit out 300 and something, we would say, whoa, time out, that can't be. Because my hypotenuse has to be the longest side, and it's only 225 feet. So just make sure you're looking for those quick reference checks. All right, let's look at inverse ratios. These are important because sometimes you don't know an angle. You can use the inverse ratio, inverse sine, inverse cosine, and inverse tangent to determine the measure of an angle when its trigonometric ratio is known. We just practiced how to find an unknown side, but how do you find an unknown angle? This is when you use the inverse ratio. For acute angle A in right triangle ABC, you would use inverse sine, sine A, to equal angle A. Inverse cosine for cosine A to find angle A, and inverse tangent for tangent A to find angle A. The sine function, which on the calculator button is sin, takes an angle and gives us the ratio opposite over hypotenuse. Remember our acronym SOHCAHTOA, SA, S-O-H, and then CA is C-A-H, and TOA is T-O-A. When we're talking sine, we're using the SA part, which is opposite and hypotenuse, opposite and hypotenuse. So the sine function takes an angle and gives us the ratio opposite over hypotenuse. But inverse sine, which is on a calculator, it's the button that says sin with the little superscript that exponent -1. We call that inverse sine. It goes the other way. It takes the ratio opposite over hypotenuse and gives us an angle. So when you have an angle I'm going to see if I can complete this diagram here. When you have an angle, you're going to use sine to give you opposite over hypotenuse. If you have opposite over hypotenuse and you're trying to get to an angle, you use inverse sine. Let's practice. Here on the board in front of me, if you're following along with our Zoom slides, I have a diagram of a ladder leaning up against a wall. And the question says, what is the angle between the ladder and the wall? So we can redraw this as a triangle. We know that the wall to the floor is a right angle. It's 90 degrees. So what we're trying to find is the angle of where the ladder is leaning at the top up against the wall. And it wants to know what is that angle. So that's our angle of reference. What is this angle? So our angle of reference. The first thing that we want to do is find the names of the sides that we know. We want to label. We want to name our sides. So if our reference angle is angle X, then opposite of that is side X, or our opposite side. Then we have our right angle, and always opposite our right angle is our hypotenuse. And we can name this triangle whatever we want. We could name it ABC, we could name it XYZ, you can name it whatever you want. The important thing is that we're naming the sides. So we know the opposite, we know the hypotenuse, and that leaves our adjacent side. But there's nothing on the adjacent side that we know. There's nothing there. It doesn't give us any kind of measurement. Whereas opposite angle X, the length of side X is 2.5, and it doesn't tell us if it's meters or feet or whatever. It doesn't say, and I always say make sure that you use your units of measurement. This one didn't. The hypotenuse side tells us 5. So again, we don't know if it's 5 feet. We can assume that we're talking feet, but it doesn't tell us. So for the sake of argument, we're going to say that our opposite side is 2.5 feet and our hypotenuse is 5 feet. So we have named the sides that we know. Now we're going to use the phrase SAKATOA to find which ratio to use. So sa is sine. That's if we have opposite and hypotenuse. Ka is, we use cosine if we know adjacent and hypotenuse. Toa is tangent, that we would use if we have opposite and adjacent. We have opposite and hypotenuse, so we're going to use sine. Next step is to substitute the values. We're going to plug it in. Sine X equals opposite over hypotenuse. Sine X, we don't know. We don't know what the angle is. That's the whole, we have to find what is the angle. So we're going to keep that sine X. Opposite is, we're saying 2.5 feet, over hypotenuse is 5 feet. So we can solve this. We can say sine X equals, we don't have to cancel anything out, move anything over, get our variable by itself just yet. Dun dun dun, wait for it. We can simply take 2.5 feet and divide it by 5. So what is 2.5 divided by 5? Sine X equals 0.5. Now, that doesn't mean that our angle is 0.5 degrees. We still have to get x by itself. This is where we need to get x away from sine. How do we get x away from sine? How do we cancel it out? We use our opposite operation, which we just learned about, is using sine inverse. Sine inverse cancels out sine and leaves just x, but whatever we do to one side, we have to do to the other. Sine inverse cancels out sine, leaving us with just x equals sine or inverse sine, and in brackets we say 0.5. We need to find that inverse sine on our calculator. If you're using Desmos, you'll see it's not on our main screen. The main screen has our squared, our exponent, we've got square root, we've got pi, we've got sine, cosine, tangent, but we need inverse. So we're going to look at this function button and click function, which is going to bring us to a new set of buttons on another screen. If you're looking at a scientific calculator, often you'll have a button that has lots of different writing above it in a different color. When you see something in orange above, so sometimes you might be looking at your scientific calculator and in a different color, it could be yellow, it could be orange, you'll see inverse sine. That was really hard to write. Let's try that. You'll see inverse sine, and you think, but I can't push that button. It's just writing above the button. Sometimes what you'll see is you'll see this function, and it will be written in the same color as the writing above your button. Sometimes it'll say second or shift, but the colors will always match. So if you have writing above the sine button and it's in green, look for another green button, one that says function or shift. When you click that button, then click the sign, and it will be your inverse or whatever the writing is that appears. It's kind of hard to describe without seeing your calculator and what yours looks like, but if you're using Desmos, and this is why I like to use Desmos in our classes as an example, because anyone and everyone can access Desmos. So if you don't know how to use your calculator, jump online, click in Desmos Scientific Calculator, and you'll see the same screen that I have, and you'll know how to work it. We're going to click this. I'm going to pull up my laser pointer here. We're going to click on this function button. This function button here is going to be what we're going to push to bring up our second screen that has that inverse sign. Now you can see it has sine and then that superscript almost to the exponent of -1. That's inverse sine. Then I'm going to go back and click my main. So now that tab main brings me back to my main screen, and I can type in 0.5 and close the bracket. Then I hit enter, and I can see that inverse sine equals 30. So that means x equals 30 degrees. There we go. And that's it. When you want to find an angle, you do the opposite of sine to get the angle by itself, so you're using the inverse ratio, just like we talked about on our slide. Let's try another one. This next question says, determine the missing angle. So if we think back, what are our steps? The first thing we want to do is we want to identify our sides. Our unknown angle is marked as angle x, so that's sort of that highlighted, we do that curve. That's our angle that we need to identify. So across from that is our opposite, and then always across from our right angle, and the longest side is our hypotenuse. We've named them. Now we need to determine, are we using sine, cosine, or tangent? We have opposite and we have hypotenuse, so we're using SAW, the first part of our acronym, which is sine. Now we know that we're using sine, which equals opposite over hypotenuse. Then we get to plug it in. We plug in our knowns. We want to find angle x, so we say sine x equals opposite is 30. Again, there's no unit of measurement. So it's just going to be 30 over hypotenuse is 40. So 30 divided by 40. We're going to carry down sine x, and we're going to actually calculate what is 30 divided by 40. We get 0.75. Now we want to get that x by itself. We want to get x because that's the angle that we're trying to find. It's attached to sine, so let's do the opposite operation. Let's do inverse sine, which will cancel it out, but whatever we do to one side, we have to do to the other side. Now we're left with x equals inverse sine. In our brackets, we're doing 0.75. On Desmos calculator, we're going to hit that function button, go to inverse sine, go back to our main tab and type in 0.75 and close the bracket, hit enter. X equals 48.6. So we can say x equals 49 degrees. So angle A, that unknown x, is 49 degrees. We could even call it, instead of sine x, we could call it sine A because that is our angle. This triangle is actually labeled ABC. Because they didn't put in this rounded to identify this is our marked angle, they used an x. You could have written in sine A equals 30 over 40. Sine A equals 0.75. A equals inverse sine 0.75. Angle A equals 49 degrees. And that's how we find our missing angle. We use inverse sine to find angles. We use sine ratio to find the length of a side. Let's practice cosine. Cosine is the ratio which can be used to calculate an unknown angle or an unknown side in a right triangle. To find either of these unknowns, when we're dealing with cosine, it's the adjacent side and the hypotenuse that are used from an angle of reference. Cosine always uses the hypotenuse and the adjacent sides of a triangle. So we're moving from the SA of our acronym SOHCAHTOA to the CA. This is when you have angle A is acute angle in a right triangle. Cosine A is the length of side adjacent angle A divided by the length of the hypotenuse side. So cosine equals adjacent over hypotenuse. Let's try a practice and we'll see if you can figure out which one are we going to use. I wonder. Find the value of x to determine the missing side length. We want to know x. We have a right triangle and opposite the right angle is our hypotenuse. We have our referenced angle. Across from our referenced angle would be our opposite, meaning the last side, the side adjacent to, next to our referenced angle, is the adjacent. Now, we don't have anything for the opposite. All we have is adjacent and hypotenuse. So we look at sa, ka, toa. We have hypotenuse, so we can't use tangent. We have adjacent and hypotenuse, so we're not going to use sine because we don't know the opposite. We're using, ding, 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 you guessed it, we're using cosine. We're going to say cosine, and here it's 47 degrees, equals adjacent over hypotenuse. So cosine 47 degrees equals, adjacent is x. We don't know what it is, but our hypotenuse is 3. Just like we've done before, we want to get x by itself. To get x by itself, we have to do the opposite operation of division, which is multiplication. Cancels that out, but whatever we do to one side, we have to do to the other side. So that's going to mean that we are now left with cosine 47 degrees. And my ink just froze. I'm waiting for it to catch up to me. Here we go. We're going to say cosine 47 degrees times 3 equals x. And we get to just type that in. Now we're going to use the cosine button. 47 degrees goes into the brackets, times 3 equals x equals 2.05, we'll say. Because it's a whole number on our diagram, you could also just say x equals 2. The next practice question says to calculate the missing angle. We're going to calculate the missing angle. So same thing. Always identify your sides. It's telling us for the above triangle, A equals 12. So we're going to put 12. H equals 30. And we have a referenced angle here. So opposite the referenced angle is our opposite. Hypotenuse is next to the opposite, not next to, opposite the right triangle, and adjacent. So I have numbers for hypotenuse and adjacent. So we look at sa, ka, toa. We're not going to use tan. We're not going to use sine. We're going to use cosine. So cosine, our angle, is adjacent divided by hypotenuse. Now we don't know our angle, but we do know adjacent is 12 and a hypotenuse is 30. So we get to just divide 12 divided by 30 equals 0.4. Remember, it's the angle that we want to find. When the angle is missing, we want to find an angle, we have to use our inverse cosine. And it's like trying to break up that cosine. We want that cosine out of the way so we get angle by itself. We do the opposite operation. Now we're doing inverse cosine. But whatever we do to one side, we have to do to the other. So inverse cosine cancels it out, leaves us with just angle equals inverse cosine 0.4. Go to our function. Now we're going to look for inverse cosine 0.4. Close your bracket. And we have our unknown missing angle is 66 degrees. So it's the same steps, whether you use sine, cosine, or tangent in how to substitute and solve for, cancel out, get a loan. But the sides we're working with determines which operation we use, which trigonometric ratio. Our last ratio is tangent. The tangent ratio can be used to calculate an unknown angle or an unknown side, just like sine and cosine. But to find either of these unknowns, the adjacent side and the opposite side are used from an angle of reference. So we're looking at our last one. Tangent always uses opposite and adjacent. Tangent angle A is equal to the length of side opposite angle A divided by length of the adjacent. Tangent equals opposite over adjacent. So I'll bet you can guess what our next practice question is going to be using. Here we need to find the value of side x. We want to determine the missing side length. We have an angle of reference. We have 67 degrees. So opposite angle 67 is our opposite side. Opposite the right angle is our hypotenuse. And beside our referenced angle, adjacent to it, is the adjacent side. So here we have no information about the hypotenuse. All we have is opposite and adjacent. Using the acronym SOHCAHTOA, we don't know anything about the hypotenuse. So that gets rid of sine, that gets rid of cosine, and leaves us with tangent. So tan equals opposite over adjacent. Here we have tangent angle 67 degrees. Opposite is our unknown, so we keep that as x. Adjacent is 14. We want to get x by itself, so we're going to use the opposite operation and multiply by 14. That cancels out our 14, but whatever we do to one side, we have to do to the other, leaving us with tangent 67 degrees times 14 equals x. So plug it into your calculator. Tangent, we're using that tan button, 67, close your bracket, then multiply by 14. We get x equals 33. X equals 33. The next practice question that we're going to get in before we run out of time here is let's find a missing angle. Always go through your steps of naming your sides. Here we have our angle of reference is angle R, but that's also what we want to know. That's our unknown. So opposite angle R is our opposite side. That's 27. The hypotenuse is always across from the right angle. And next to, or the last remaining side, is our adjacent side. There's no information about our hypotenuse. All we know is opposite and adjacent, so you guessed it, we're going to use tangent. So we're going to say tangent R, because that's our angle, equals opposite over adjacent. R is unknown, so we're going to keep it as tangent R. Opposite is 27, adjacent is 18. So we need to find what is 27 divided by 18. We get 1.5. We're going to use the inverse. Tangent inverse cancels it out, leaving us tangent inverse, which says R equals inverse tangent 1.5. We type it into our calculator looking at inverse tangent 1.5, nope, not 15, 1.5. There we go. Gives us R equals 56 degrees. So that's it. Make sure you go through the steps of identifying your sides and then finding out if you need to find a missing side, you're just going to use sine, cosine, or tangent. If you need to find a missing angle, you use inverse sine, inverse cosine, inverse tangent. That's all the time that we have for today. Tomorrow we will jump into lesson 18 and